We have big D, of course, 0.75 inches per foot is our taper. Big D is 2.5 minus little d, which is 3/4, over L over 12. So we have 2.5 minus 3/4 first, which is 1 3/4 over L over 12. So I next have to combine 0.75 we're not going to do anything with yet. I'm going to take 1 3/4 divided by L over 12. So 1 3/4, 1 times 4 is 4, plus 3 is 7/4. Dividing by L over 12 is times 12 over L. Cross cancel the 4 and the 12 to get 1 and 3. So 7 times 3 is 21. 1 times L is L. So we have 0.75 equals 21 over L. So I'm going to complete the proportion by making that a 1. I'm going to cross, multiply, and divide. 1 times 21 is 21, divided by 0.75 is 28. So this is 28 inches long. Any questions? How many of you got 28 for that one? Nobody? Okay. Well, let's see if we did better on this one. So our taper, 1.5 inches per foot, equals big D of 2 1/4 minus little d, which is what we're trying to find, over L, which is 8 over 12. Now, I'm going to have to multiply by the 8/12 to get it off the bottom. So I'm going to turn the 1.5 into an improper fraction. So that's going to be 3 halves. Multiplying by 8/12. So multiplying by 8/12 gets rid of that. 3 halves times 8/12 is 1. So I'm going to rewrite that so I have a little bit more room to work. So what I have there is 1 equals 2 1/4 minus little d. Solving for little d, I have to get rid of the 2 1/4 by subtracting. It is positive, so I subtract it. 1 minus 2 1/4 is a negative 1 1/4 equals negative d. I think of that as being a negative 1d. I divide by negative 1. So it's 1 1/4 equals little d. So d is 1 1/4 inch. Anybody get that one? A couple of you?
Well, go back to the first one. I got 2 1/3.
2 1/3 for feet. You didn't have the over 12 here. You just had L on bottom. You didn't have L over 12.
I did L over 12 times 0.75 equals 2.5 minus 0.75 divided by 0.75.
You had the 0.75 in there twice.
Yeah, for the 0.75 equals. And then 0.75 equals.
2.5 minus 0.75, right?
And L over 12 times 0.75.
So you're going to multiply
For the first one.
0.75 by L over 12.
Yep.
So now it's gone over here.
Yep. And
Okay.
now I divided 0.75 to get it over
Okay.
from.
So first you made this 1.75, right?
Divide by 12.
You have to multiply by the
Multiply
12.
by 12.
Yeah. So what you're getting is L over 12 is 2 1/3. That's 2 1/3 feet, which
Yeah.
is 28 inches.
Yeah.
So you're half a step away from it. Similar problem. Let's say this is 2 3/4 inches. Our taper quarters of an inch per foot. Find the length for this to taper all the way down to a point. See if you guys can figure that out quick. Okay, so taper 3/4 of an inch per foot equals big D of 2 3/4 minus what? 0 over L over 12. So let's multiply by L over 12. It cancels that out. 2 3/4 minus 0 is just 2 3/4. 3 and 12 cross cancel, give me 1 and 4. So this is L over 16 equals 2 3/4. We are going to then multiply by 16. So times 16 cancels that out. 2 3/4 times 16. Well, that's 2 times, that's 11/4. Times 16 over 1. 4 and 16 cross cancel, give me 1 and 4. 11 times 4 is 44. Yeah, what'd you do?
Yeah, me too.
Just put this over 1 and cross multiply and divided?
I saw that.
Oh, sure.
I had,
Just rearrange the
so I had
formula.
11 over 4 times 12 over L. And then I cross canceled and then I multiplied. I got 33 over 1, 0.75 times 33. I agree with that.
11 over 4 equals 12 over L.
Just like we did in the last one.
I just took 2.75 divided by 0.75.
11 over 4 times 12 over L.
Yeah.
Yeah, that works.
I just took 2.75 divided by 0.75 and then multiplied that
By the 12.
Yeah.
Yeah, basically what you did was this.
Yeah.
You put that over 1. You cross multiplied and divided. So you got L over 12 equals that number. Then you multiplied by 12 to find L. There's a lot of different ways you can go about solving these. And you did the 2 3/4 divided by the L over 12 equals 2/4, and then you solve from there. Same type of deal. How many of you had 44 inches? Good deal. Okay. So that is direct proportion. And remember, there are a lot of applications of direct proportion. For example, one example of a direct proportion is a feed rate. Let's say your feed rate is 0.03 of an inch per revolution. You want to know how far you can go in 200 revolutions. Well, again, this is just a proportion. Feed rate, 0.003 inches over 1 revolution. You have to be able to write that as a rate like that. Put it out as a fraction. What's going to go on the other side? Where's the 200 going to go? Bottom, because it is revolutions. So now we can cross multiply and divide. 0.003 times 200 is 0.6. So you get 0.6 inches in 200 revolutions. Not so bad. Well, today I want to take some time to talk about inverse proportions a little bit. In inverse proportions, inverse relationships, one number gets larger, the other has to get smaller, or the other way around. So inverse proportions. An example of this goes back to our gears. Now in our gear ratio, there is a direct ratio if you're counting teeth. So let's look at gear ratios here. In a gear ratio, let's say we have a system that requires a 5-to-2 gear ratio. We have a motor that has a gear on it with 12 teeth. We want to know how many teeth do we have to have on the other gear. Is this direct or inverse? This is direct. The number of teeth on the motor get larger, the number of teeth on the other gear has to get larger. We have to maintain that ratio. So I've got a 5/2. Which one of those, the 5 or the 2, represents the motor? The 2, right? Driven over driving, the motor's the driving. So I put 12 on bottom, cross multiply and divide, I get 30 up here. We need 30 teeth on the other gear. That is a direct relationship with our gear ratios. Where an inverse relationship would come into our gear ratios. Let's say we now have the 12-tooth gear. And I'm not going to bother drawing them in because I won't space them right anyway. And a 30-tooth gear. And let's say our motor runs at 300 RPM. Will our 30-tooth gear turn faster or slower? Slower. Because the number of teeth that go through the intersection of the gears here has to be the same from each gear. The small gear turns, 12 teeth go through, well, only 12 teeth of the 30-tooth gear go through. It only goes partway around. This is an inverse relationship. The number of teeth gets larger, the RPM gets smaller. Now your book and your packets do some weird stuff with taking a ratio and then flipping the other ratio. The easiest way for me to look at this inverse proportion is it's not a constant ratio. A direct relationship is a constant ratio. That's where we set the two ratios, the two fractions equal to each other, and we can cross multiply and divide the proportion. An inverse relationship is a constant product. So it is the size times speed has to equal size times speed. So what does that mean? Well, that means this first gear has 12 teeth and is turning at 300 RPM. That has to equal the second gear has 30 teeth and is turning at X RPM. So to solve this, it's still going to be multiply and divide, just not cross multiply and divide. 12 times 300 is 3,600. And then we would divide by 30. Get 120 equals X. So that bigger gear is turning at 120 RPM. This will also work with pulley ratios. A lot of what we're going to do is pulley ratios just because then I don't have to draw teeth on gears. So let's say we got a 10-inch gear, or 10-inch pulley, and a 3-inch diameter pulley. Does it matter whether we can compare diameters or radii? No, the ratio will be the same. And let's say that this 10-inch pulley is turning at 240 RPM. So I would set this up. 10 inches times 240 RPM equals 3 inches times X RPM. 10 times 240 is 2,400. Then we divide by 3. 800 equals X. So the smaller pulley is turning at 800 RPM. So let's say we have a 6-inch pulley here, turning at 480 RPM. And we have a bigger pulley here, turning at 360 RPM. Find its size. I'll give you a second, see if you guys can make that one work. So 6 inches times 480 RPM for the first pulley equals X inches times 360 RPM. 6 times 480 is 2880 equals X times 360. Divide by 360. X equals 8 inches. Not so bad. Another application, this might be a pump. Let's say you have a pump that can empty a pit in 20 minutes. Operating at 12 CFM. Anybody know what CFM means? Cubic feet per minute. How long would it take an 8 CFM pump? Well, here's the same thing. This is a smaller capacity pump. Is the time going to go up or down? Up, right? The capacity of the pump went down. The time has to go up. This is an inverse relationship. So that means we're going to go with that constant product. The 12 CFM pump took 20 minutes. An 8 CFM pump will take X minutes. 12 times 20 is 240. Is 8 times X. Divide by 8. 30 equals X. So it took 30 minutes for that 8 CFM pump. What do you think? Okay. There are some questions in the packet from yesterday that I will go over. Just not today because I'm losing my voice. So I got to save my voice to for the rest of the day a little bit here. Added to what we did yesterday. Yesterday in the packet we assigned 31 through 39 and then 42 through 45. But today I'm going to add to that 40 to 41 and let's see here. basically, we can go up to 71 now. So 46 to 71. So that means in that packet, that's the one that has the measurements on front, the operations with measurements on front, you should be able to do all the way up to number 71. Now there's another packet I'm about to give you. Actually, I think it's already in the packet you have. It's this packet that says Unit 39 on front. Page 234 through 236. So it's the Unit 39 packet. Page 234 to 236. 1 through 10 there. I realize it's a lot of work. I'm going to give you guys the last 22 minutes here to start working on them. On Monday, hopefully I have a little bit more of a voice back. And on Monday, we'll go through some of the problems out of the packet, give you some work time, work through some of them together. At least hopefully that works out.